me add myself to the stage. Ooh. Yep, that's me. Cool. Just let me know if the music is either too loud or too low. Okay, kind of like this one. It's like a cool version of a guitar. Second stream of the day. Hello, whoever has or was with me with the Arduino stream, and hello people who are new. I'll be sharing. Where is it? Here it is. Give me a second. I'll share with you the link for you to register. There we go. It's in Twitch and YouTube. Nice. Okay. Cool. I think everything's good. Hello. Nice. Okay. So, quick intro of myself. My name is Bully. Well, that's my nickname. My name is Charvel. People call me Bully, so you can call me by my name or nickname. Happy to be here once again. I'm a robotics and telecommunications engineer. I am a streamer and also a pod leader for MLH. That means that I stream, as you can see, and also I manage pods for the MLH Fellowship. So if you have any questions about the MLH Fellowship or anything, don't hesitate to ping me on Discord and I'll be happy to help. Okay, cool. Presentations aside, let us start with today's interesting, or this time's interesting stream, which is about Docker. So let's see, let's add myself to the stage. That's my other computer because I use Linux, but streaming with Linux is not a good idea. So let's just slideshow. Yeah, let's do this now. Cool. Now, let me just remove the banner. I always forget to remove the banners. There we go. Hey. Cool. Okay, so let me just probably lower the volume a bit to 15. I think 15 is good. Cool. Okay, so Docker and networking basics. Okay, let's first dive into Docker and see what's Docker like. I'm pretty sure you've heard about Docker. Hello. I'm pretty sure you heard about Docker, but you probably don't know how it works or what it does. So let's take a look at that. So what is Docker? Like, what the heck are we talking about? Do you ever do events in Toronto? I've never been to Toronto. It would be cool. I'm not sure. Like I've never did in Toronto once. If you ask as MLH, I'm not sure. That's more a question for coaches. You should ask that on GitHub. They probably would know how to answer. Okay, cool. What is Docker? So, I'm pretty sure you've seen at least the icon of Docker once. Docker is a platform for developing, shipping, and running applications inside containers. So we have this thing called Docker that uses containers. Containers are lightweight, portable, and ensure consistency across environments. Okay, that doesn't say too much. A container is basically, you can see it as a virtual machine of a virtual machine. Okay, it's basically a teeny tiny fragment of an operating system. It has only whatever the application needs to run, and it's so portable that you can use it in your phone, in your macOS, in your Windows, in your Linux. It doesn't matter. Like the objective or the purpose of containers is to ship applications regardless of the operating system. That's basically it. Now, it sounds magical. I've used Docker and it still is. Is it like Kubernetes? Yes. So Kubernetes is another containerization platform. Okay. Kubernetes is used a little bit more to orchestrate a lot of containers. Okay. But we have Kubernetes, we have Docker. I know that Meta uses or has like an internal Docker, which is called Tupperware. Okay. So there are lots of platforms that you can use. But yeah, it's basically like Kubernetes. Okay. Cool. Great comment though. What is Docker used for then? Like, okay, we got this mini OSs inside of containers that can run anywhere. We can containerize applications. Some applications, and one that you're going to see later, uses only a certain specific operating system because it has a something, I'm not sure what, but a dependency there that needs to be in order for the app to live. Okay, so you use Docker to containerize and ship your app everywhere. That's basically how it works. Simplifies deployment and scaling. You can have multiple Docker containers and you can control them with Docker or Kubernetes, which Kubernetes is the best one to containerize or to actually control all of your containers. But yeah, you have a lot of platforms too. Ensures consistency across development, testing, and production. The thing is, and now you'll get to see it, is you have your code, you have something called a Docker file, which is a file that basically tells Docker, hey, I need you to build an app with these specific things. And it'll build anywhere the same app with the same specific things. So nothing will change, okay? And save system resources compared to virtual machines. So virtual machines are usually over your operating system and they get a huge chunk of your hardware. Containers don't. Containers just use the bare minimum to survive. Okay, that's the cool thing about containers. Okay, and this is how it looks. Okay, so you have your Docker container. It creates a Docker image. There's a Docker file that manages both of them, and the website. Okay, this is something that we'll see. This is actually a really good example because we are going to leverage a neural network, fine-tuned. It runs only in Ubuntu 16, I think. It's a unit, and we're going to leverage that to talk from one container to another using a Flask app. Okay, that's going to be the final project. Cool. Okay, so we talked about what Docker is, what containers are, what exactly or how do containers are created. So there's something called a Docker file, which is a text document with instructions to build a Docker image. And we'll get to see one in a second. It automates the creation of Docker images. It means you just write it once, copy paste it in whatever you want. You just put the command Docker build -t, I don't know, something in this format. Voila, it's ready for you. Okay, this is like a little bit of an example of something that you would find inside of a Docker file. It says from Ubuntu latest, so I want to use the latest Ubuntu upgrade. Run apt-get update and echo hello world. Okay, that's something that similar that we can do. Okay, cool. Now, Docker hello world. So we're going to do this in a second. Okay, I just want to get through this PowerPoint. The easiest way to test if Docker is working is to run the hello world. Okay, and we'll do that in a second. It downloads a test image and runs it in a container. If it works, it says hello world from Docker and gives you a little bit of a text, then your Docker works. If not, then you have a bad thing. So you have to either reinstall or change some permissions or something, okay? Cool. An interesting command, which we're going to use, is Docker PS. So Docker PS lists the running containers, okay? So whenever you have a lot of containers, and you want to see, hey, what was the name of this container? How much time has this container been up? All of that can be seen in Docker PS. Okay, it has an ID too. So yeah, it has a lot of things. Okay, cool. That's about Docker. Okay, now before we dive into the coding, I kind of wanted to talk about some other concepts that we are going to technically use, especially IP addresses and sockets in ports. But firstly, let's see, like, what is wireless and wired networks? Like, why would you use a wireless and why would you use wired? So wireless uses radio waves. It offers mobility. It's slower and less secure. It's like your Wi-Fi. Okay, it's basically your Wi-Fi. So the cool thing is that you can be wherever, in your house, in your company, in campus, I don't know, and you can have internet. If you want to download something, it'll take more time than if you used wired Ethernet cable or like wired networks. So usually when people just play or stream or whatever, they use wired networks just because it's easier and it's faster, but it's not that mobile. So I would not be able to move with that cable. Okay, cool. So that's something, and it's more secure because the other one can be hacked easily. If you don't have access to the hardware, then you cannot hack the wired network. Okay, cool. Now what's an IP address? So those are networks, and it allows us to talk from one I don't know, an iPad to a computer. It allows that communication, but how does that happen? So every computer in the world has a name, and there are two types of names. The first one is the name that we cannot change. The other one is the name that is given to us depending on that name that we have. So an IP address is a dynamic name because whenever you go, you'll have a different IP address. Okay, so let's say I'm here in my house. This computer here, actually, let's see it. Let's see this. Can you see this? Yeah. If I do ipconfig, you can see it's in Spanish. I'm sorry, but you can actually see this is my IP address. So my home's IP address starts with 192, 168, 100, and the number of my computer is 100. Okay. So this is a local IP address. So if you do this in your Windows machine, you may see the same 3 numbers, or probably even the same 4 numbers. Usually it's the same 3 plus another number, never 0 nor 255. It means that in my house, right here, right now, this is my computer's name. This is how other computers hear. This is IPv4, okay? There is an IPv6, which is this one, okay? It has way more bits, and it allows us for more combinations because we're running out of IPv4 addresses, okay? Cool. Now, why is this relevant? Because every computer has its own IP address, but this is the dynamic one. If you go to a cafeteria, you'll get another one. It depends on the network. If you go to something called the MAC address, it's the address of your like your networking card inside of your computer. It has an address. That address is not mobile. It's not dynamic. You cannot move that one. Okay, so those are the two names that computers get. Okay, and in this case, we can see an IPv4 address. It has a byte here, which is 8 bits. So 8, 16, 24, and 32. So an IP address of 4, IPv4, is made out of 8, 16, 24, 32 bits. Okay, IPv6s are made out of 128 bits. Okay, so that's a lot. That's more combinations that we'll ever need. But yeah, that's how it works. Okay, cool. So what are sockets? Okay, so we have an IP address. Sockets are for sending and receiving data over a network. Okay, they enable a communication between processes on different devices, and they are common in network programming like web servers. Okay, so you would use a socket. You can imagine an IP address being a hotel. Okay, inside of the IP address or inside of the hotel, we can have lots of rooms. Each room has a number. Okay, so if we try to access a number, that's a socket. The number or the room itself is a port. Okay, so the socket is the way to get into a port, and the port gives you access to something. If it's port 443, it was HTTPS. If it's port 80, it's HTTP. I think I'll be mistaken, but if it's port either 20, I think it's 20, it's for email. 22 is for SSH. So, every port has its own number, and sockets are ways to connect to ports. Okay, cool. Hopefully that made sense. It's a little bit confusing at first. But yeah, cool. Okay, that's the first thing that I wanted to talk about. Let's see some things that we were talking about. So first of all, hello world. Great analogy. Hey, thank you for that. Yeah, it's like when you try to understand networking, you have to use like real life analogies, because if not, it won't make sense. But yeah, cool, nice. Let me just bring my other computer, which has Linux in it. Um, let's do this. Cool. Okay, so you see nothing. This is because we just double check everything. This should be done. Cool. Okay, nice. There we go. Let me just double limit type here, so I don't want to have conflict there. Cool. Okay, this is my Linux computer. Okay. Let's take a look. Here's a Docker thingy. Cool. Now this is a code that I'll share in a second. Cool. Now I specifically have Docker in my computer, and I can do the Docker run. Hello world. Was it like this? I'm not sure. Ah, shoot. Sudo, okay, for admin permissions. Docker, hello world. Okay, let me just do this so it's easier to read. Was it with bugs always? Docker hello world. What? Wait a second. Was it? Docker run hello world. Ah, great. Cool. So it says it doesn't find the image hello world latest locally. This means that the image by itself, the container by itself, doesn't exist inside of my computer. So what will it do? Pulling from library hello world. Okay. This is an ID. Okay. It says pull complete. Downloaded new image. And it says hello from Docker. This message shows that your installation appears to be working correctly. Cool. Okay, nice. So do we have any Docker containers running? We can do Docker. I think I have to use sudo docker ps. I have nothing. You can see that container ID, image, command, created, status, ports, and names have nothing under it. Okay. When we create new containers, we will have information about those containers right there. Okay, cool. Nice. So let me just plug in this computer because I don't want it to get. There we go. Cool. Now, let us start. Okay, first with what we are going. What are we going to work with? Okay, so you can find this on my GitHub. Okay, it's called Dejando Huella. Dejando Huella is a service that I made like a year ago for like let's say an organization that tracks or like keeps information about lost pets. Okay, so basically the idea is you upload a picture of your dog or your cat, and with an AI, it breaks down the colors, gives us like the amount of colors that we have per each dog or cat, and you say, okay, it's a Siberian cat, and we look in the database in a I think it was like 5 kilometer radius. If there have been any Siberian cats nearby with those specific colors. Okay, so that's what we're going to work with. I made this. This says here, are you working on VirtualBox VM or something? No, this is my computer. Like this is my other computer. You can see it here. It's you cannot see it. There we go. Here it is. Okay. No, it's not like if you want to use virtual machines, cool, because you don't need any more hardware. I don't like them that much because I do use ROS, which is a robotics operating system, and I have to simulate lots of things. And because of that, it doesn't simulate that fast, so it takes a lot of time. Yep, like you use WSL on Windows. Yeah, no, I had this computer before, this one, so that's a new computer that I got like 6 months ago. This one I had it for like 4 years or 5 years, so I removed Windows from it and added Ubuntu. But yeah, because I have two computers. Actually, I have three. So I have three operating systems. I have Mac OS, I have Linux, and Windows. But yeah, yep, yes. If you have Docker on desktop on Windows, it's fine. Yes, it's fine. It should be fine. I've never used I've used it a couple of times Docker on desktop, but I do prefer like the terminal one. I'm more used to it, but it should work. Cool. Okay, those are interesting questions. So, probably what I should be doing. Let me see. Should I share my GitHub? Let's see. My repos. Okay, cool. So, if you want to follow with what I'll be doing, this one. Cool. Okay, I have this repo. Okay, from this repo, can I? No. Okay, cool. It looks. That's how it looks. Okay, in this repo, you can see that I have a README here. You basically download the whole thing and you run it with sudo docker build dash t and then sudo docker run, and you can add pictures with this. Okay, we'll be using these two. Okay, so if you want to follow with me or follow me, just copy this. I'll be sending it to you. um, it's pet classifier unit. Give me a second, let me just try to find it. Let's see if I find my. Nah, I should open GitHub. Cool. Sign in. Am I not signed in? What? Give me a second. This should be pretty fast. Let's see. My repos, and then here it is. So this is the AI model that I'll be using. Okay. Cool. There we go. Yeah, it did on some TMD2. Nice. So yeah, I should be working. Like that's the cool thing about Docker, and it's that it should be working anywhere. Okay. Cool. So I downloaded this on my computer, but I kind of want to go first, like to see what it actually does. So from TensorFlow datasets, I took a dataset that's called Oxford IT pet. It has a lot of pets. Okay, it has dogs and cats. I'm not sure if it had more pets than those, but yeah. Basically, what I did, and this is Google Colab. For anyone who doesn't know, this is a Google service that gives you access to free. Let's see. To join the tab, so you have access to a cool CPU, to a T4 GPU, or to a V2 TPU. TPU stands for Tensor Processing Unit. It's used for AI or deep learning, basically. That's for free. If you pay, which I currently do not, you can use an A1000 GPU, L4 GPU, and a V5E TPU. Yeah. So, but with the free version, it should be working. Okay. Cool. So this is Google Colab, and you use Python here. Nice. So I'm using TensorFlow, which is another Google deep learning API. Clone. Let's see. Should be main. Yeah, clone main. Main should be good. Cool. Nice question though. Nice. So I use TensorFlow. And here I won't explain every single step because this is not a deep learning stream. I just kind of wanted to show you that we loaded images. Everything was 128 times 128. What are you running a separate Google Colab notebook? That's a great question. This computer doesn't have a GPU. Like it has an integrated one. It runs really slow. When you are using or basically working with computer vision or anything that has to do with basically computer vision, a GPU is recommended. Okay, I don't know why I have a T4. Yeah, it's a T4. That's normal. I use a Google Colab notebook, so it runs on a cool GPU and not mine, which would take ages. So yeah, that's basically it. Because in that computer over there, I have an RTX 4050, but yeah, I still use Google Colab. Look, if I break something, I know that I won't, trash anything. But yeah, that's the reason. Cool. Okay, I clone Colab. No. Clone it locally, and we'll program my Python thing. I'm just sharing what like how is the neural network built. Okay, cool. So quickly, we augmented. Augmenting means giving more or adding more noise to an image. Okay, so you can either shift, reverse, change the colors to an image, stuff like that. Here we have batches, which helps us segment images. Like instead of sending or giving the neural network like, hey, there you have 5,000 images, you send groups or batches of, I don't know, 500. In this case, I think it was, I'm not sure. It was 64. Okay, so 64 images per iteration. Okay, cool. Another thing here is that we plotted some, how did this look? And basically this neural network, what it does, it's called unit. It has a U shape. What it does, it basically segments dogs and cats. Okay, so you can see here is the image of a pug, and this is the true mask. Okay, so the neural network should be able to do this. Okay, cool. Now here we have another one. This is a Doberman? No, it's not a Doberman. I'm not sure what this breed of dog is. But yeah, here you can see that blue or this green is not what we want. We want the purple. Okay, cool. Now, basically, here we add a little bit more nuance to the neural network. What we do here is this is upgrading the images. Okay, and then here it's the unit model. I take it from where it is. You can see, and it's really cool. It's really easy. Basically, this is a model. Like it's a very, very, very complete neural network that will be like, it looks like this. All of these neurons are inside of the neural network. So that's crazy. And you can use it as simple as, like, I can keep scrolling and it never ends. Who did this? I'm not sure. Kudos for all of the people who did or create new like unit, especially also people who are working on TensorFlow, because it makes it really easy to use. So basically, we plotted the model. This is how it looks. And when we basically, after predicting, we can see that this is the input image. This is the true mask. This is what we predicted, which is really similar. And this image plus this image gives me this double. Okay, this goes on. Yeah, it goes on, and it's basically in a U shape. Okay, so it's crazy. Like, I don't know how people are just really smart. Cool. Okay, after that, it's really easy. You can save the model, and I saved a binary file. Okay, now why is this important? Why did I share or show you all of this? Cool, bear with me. So we go to VS Code to the, no, it's not this one. It should be this one. Cool. So we can see that the repo that I shared, it's inside of this. That's too much. Cool. So you can see that here's colors, app, this is the pet classification, and here we have the Docker file. So let's take a look at that first. What are we saying? Okay, so Mr. Docker, give me Ubuntu 20.04. Why? Because unit, that specific unit only works with a TensorFlow version that's only in Ubuntu 20.04. That was the problem of this application. So I had to research for 2-3 months up until I figured out that I could use Docker for it. Okay, so that's the first thing that you have to add is from Ubuntu, give me this. Okay, you can use Windows. I'm not sure if you can use macOS, but you can definitely use Windows in other operating systems. Okay, you can use Raspbian for Raspberry Pi, whatever. It says here, run apt-get update. We update whatever's inside of the container. We apt upgrade, and then apt install Python and Python 3 pip. Okay, why? Because we need Python and we need pip. Because after that, I'll run pip install requirements.txt. Whoever doesn't know what this means is that I have here a document which tells me I need 4 things. The requirement is TensorFlow bigger than 2.0, Matplotlib, NumPy, and Flask. Okay. Where is it? Shoot, there. So in the end, the commands are Python 3 and then app.py, which is run. Okay, so this is what the Docker file does. Okay, in the end, what it'll run the app.py, which is this whole thing. Okay, and this whole thing will use this other whole thing that we will take a look after we have coded. Okay. It says this is an interesting question. What's work there for? Cool. Okay. So if you don't give it a work there, so it's essentially the name that it'll be using to run the container. Okay, so you have to have like a direction or like a directory of where it'll be installed. Okay, in the end, I don't have that directory. It'll be created inside of the Docker container. But if you don't give it a directory, it won't have anywhere to basically to install everything. Okay, it'll tell like, hey, I don't know where. Like I have apps, I have etc. I don't know where. So basically, I'm telling him, hey, please create servicio social and install it there. Okay, that's basically how it works. But you can leave it there. That it'll be fine, or you can add another name. Okay, both of them are fine. Cool. So, how does this look? So, ignoring for now that we have to do first. I think I have to do sudo docker build -t. Yeah, and we do shoot. Was it pet classification? Was it like this? I'm not sure. Yeah, cool. Okay, so when you run that command, the first thing that we do, or the first thing that Docker does, it's I'm getting everything from Docker file, and you can see it here. I'm reading from Docker file 256 bytes. Okay. It says here, copy means copy from the previous dir. Yes, exactly. What we want is copy from one dir to another to have it everything in one. Yep. Cool. So in the end, yeah, cool. So now we have that. We're loading the Docker ignore. I'm not sure where this is at, but I don't know if it exists, but I think it's like an internal thing, which we won't be taking care of. It says here, from docker.io library, I'm taking Ubuntu 20.04, the one that we needed. Then after that, I remember that it said run apt-get install Python 3 and Python 3 pip. Voila, here it is. Run apt-get update, upgrade, and install. So it's basically like a bash script waiting for you to activate it. Okay, it takes a little bit of time because it's downloading lots of things, including Flask, Jinja, Click. It says here error TensorFlow has requirement NumPy, blah blah blah, which is incompatible. That's okay. As long as it's not a big error, it's okay. Cool. I tested it yesterday. It should work. Step 5 of 5, run pip3 install requirements. Okay, and that's what it's doing. So it takes a little bit of time just because it's creating a Docker container. Okay, cool. No errors. When we have errors, big red rows of errors will pop out. So all blue means all cool. Okay, nice. So what will we be doing? Sudo docker ps. Aha. Okay, so why isn't it running? Like we built it. We used sudo docker build -t pet classification. Why isn't it running? Like we built it. Cool. You built an image. An image is basically the backbone of a container. It's not the container per se. It's just backbone. Let's run it. Docker run pet classification. Was it like this? Ah, shoot. Sudo docker run pet classification. Cool. Okay. It says something. TensorFlow could not find CUDA drivers on this machine. So answering the question of Sakith, I'm not sure if I'm pronouncing your name correctly. Because of that, I don't have GPUs on this computer, and because it's Linux, so that's why I'm using it. Okay, Colab, yeah, Colab. Cool. Okay, nice. So we have something here. Remember, we talked about IP addresses. We talked about what they were, And actually, we can check this IP address. If we do IP address show, we can see here the one that we are interested in is this one. Yep, we have 192, 168, 100. Remember what my computer said, my Windows? Just take a look. 192, 168, 100. See? But my Linux machine, its number is 2. See that? That means this is number 2, that's number 100 in the house. My phone could be number 4, my iPad could be number 5, number 1, number 25, up until 254. Okay, cool. Now, we have an IP address here, but this is another one. What is this? So it says HTTP 127.0.0.1 colon 5000. What is this? Like, what does this mean? Let's click on it because it's clickable. Let's see what it does. Oh, it says this site can be reached. Okay, there's an interesting thing here. What if I do slash classify? Was it classify? Let me double check that. Yeah, classify. Okay, classify. Okay, cool. Now, why wouldn't this connect? Like, it's running, and let's double check that it's running. It's probably not running. Oh, it is. We can do docker. Okay, sudo docker ps. Oh, now we have something. Now we have container ID, which is this one. Let's do this. Container ID, image, path classification. That's what we wanted. Command. What did it run? Python 3 app.py. Okay. Created 2 minutes ago. Status, it's been up 2 minutes. It's not working literally on a port. It should say 5000, but let's just say it's not working on 5000 because it's not the actual Docker container that has to work on that port. It's the app. Okay. And Lucid more, I'm not sure why this is here. Okay. But yeah, cool. Okay, so let's see. Wait a second. What? Oh, there you go. Cool. Now, okay, so let's do that again. We go to the IP that we've been given, and this IP says it can be reached. Why is that? Actually, what is 127.0.0.1? This is called localhost. Okay, localhost is an IP address that your computer creates for itself. Okay, it hosts stuff in that IP. Okay, so 127.0.0.1 is your computer talking to itself. Okay, now remember we had this is the hotel. We are socketing into this port over here. We are going into room 5000. Okay, which socket are we using? I'm not sure. We have to check it with Linux commands, but we know that it's port 5000. Okay, so in Linux Hotel, 5000 is being used by this app. Okay, I hope that makes sense. So actually, let me do something better. Yeah, that should be better. Okay, cool. Nice. So this is not working. Why are we looking at this? Let's make it work. Okay, cool. Now let's just read a little bit more before we code. This is the app. Okay, this is the Flask app. Let's just remove this and this. So we are using Flask. Flask is a Python API, or not, it's not an API. It's a Python. Shoot, I forgot the name. It's a Python, one of these that you can import and use it for. Thank you. Yes, that's it. Thank you so much. It's a Python library. Yeah, thank you very much. It's a library that allows you to work with web servers and web pages. Okay, so it's easy to use. Is it the best? Probably not, but I'm used to it and it works. So yeah, cool. So we are saying, okay, basically what it does is I want to create an endpoint. An endpoint is basically this. This is an endpoint. Okay, So it could say google.com/help. If we do, I don't know, if we do this, and then I go here and here, you see, this is the domain name, and this is the endpoint, which is my username. Okay, cool. So this is the endpoint over here. So inside of that endpoint, the only methods allowed are post. Okay, I use Python Streamlit because it's easy. Okay, never used Streamlit before, but if it's easy, then yeah, whatever fits your needs, it's fine. Cool. We have post. What post means? It means I won't be render anything. I will be just listening to stuff. Now it makes sense. It won't render anything because in the end, we do not ask it to render something. This is an API that we created. So we will take an image, save it in input images. If there is no image, then just throw an error. And the most important part is this tree. This tree, I won't dive into this file here, but where is it? There we go. This whole file is an object that works with the neural network that we saw before. Okay, it basically will give us the colors inside of this mapping over here. So I created this map. So and then we do an Euclidean distance to check which color would fit more. So just to explain it pretty fast, dog. Cool. So this dog over here, it would have a lot of red, a lot of white, okay, probably some gray areas, okay, black. We don't have any pink, so instead of pink, it probably will be orange, okay. And why did we do this? Because colors are infinite and colors depend on the light. So if we want to break down the primary colors to match in a database, we needed 5 or 6, and these are the ones that we chose. Okay, and you'll see why when we start coding. Okay, that's what it does. In the end, it returns the JSONify colors. Okay, so this is the API. Okay, this is something that will work in the background with us. Let's use it. So let's start. Let me just open my GitHub because I need my cheat sheet. Where is my Mr. Cheat sheet? There we go. Cool. Okay. By the way, the code that we'll be writing, it's on my GitHub too. I won't share it just so we can write it together. Okay. We will use the API, this API, which is in my GitHub that I just shared. Okay. Cool. Okay. So, oh, by the way, here we can see the host should be myself in port 5000. Okay. Cool. Yeah, exactly. It just reads. It doesn't actually render because there's a function in Flask that says render. But we don't want it to render. It's just an API. It just listens and waits, basically. It just computes the neural network and then sends back the answer. Cool. So close this Visual Studio. Let's close this other one. No, not this one. Yeah, let's do this one. Okay, cool. So, cool. Now, let me just get rid of this. Let's see, unit app. CD unit app. Okay, cool. Okay, cool. All of that just to open a new folder in Visual Studio Code. Okay, don't worry. Cool. We have it here. Okay. What? Ah, got it. Sorry. I opened the other one. CD unit app 2. There we go. Sorry. That happens when you rename stuff. Practically the same. There we go. Cool. We have Visual Studio, okay? Now, first things first. This app will work if you have an env or an env, a Python env, basically. Okay, so in Linux, to create a Python environment, you have to do pi. Was it pi? I know it's Python 3 dash m v. Okay, that's the command, and then you give it a name. The name that I always give my environments is env. Okay. For Windows, instead of Python 3, it's py only. py-m v, and then env. Okay, cool. No errors. Now we can check that we have an env folder. Okay, it means that we can add Python libraries without them installing directly in our computer. Okay, because when you're working in a project and you don't have an env, then everything that you install will be directly in your computer, and when you get rid of it, you won't be using it anymore. It's just junk files. Okay, so that's how it does. Okay, cool, nice. So let's see. First things first, we have to create something called app.py. It has to have that name though. It has to be named app.py. Okay, cool. Now we will be importing important stuff. Just select the interpreter just so it doesn't look weird. Cool. Now import Flask. Actually, from Flask import Flask render. Oh, come on, Flask render template and request. There we go. Cool. Now that's what we need. If you can see, Flask, it's like could not be resolved. What happens there? Okay, we go to a terminal, pip install Flask. Shoot, no. Damn it. Okay. No, I forgot one step. Activating the environment. So in Linux, you do source, bin, actually it's env, bin activate. Okay. For Windows, it's in env, bin activate. Okay, you just don't use the source. Okay, cool. Good job. So we can do pip install Flask. There we go. Now we can do it. There we go. It's doing its own thing. In the meantime, let's just keep on typing. Import requests. Okay, and import OS. Cool. Now, those are the things that we need. Again, you can see that requests is not a library that's by default installed in Python, so we have to install it. Okay. There we go. Flask is installed. Import request. What? Why did I type import? What's happening? Pip install request. Today, my typing today hasn't been the best, huh? Like last stream was weird. I typed bad. Cool. Okay, now if we refresh this, it should disappear. But yeah, basically those two are already installed. Okay, cool. Now, first things first with Flask, app equals Flask under name. So why we do this? Because Flask doesn't know which app is the app. Okay, that's why we have to call this app. So Flask understands it. Okay, so basically we're saying, hey, this is the main app. Listen to this one. Okay, cool. No worries. Thank you. Yeah, typing sometimes your hands just don't type at all. Oh, cool. Okay, now let's connect to our API. Okay, let's do connect to API. Okay, so API URL equals basically, if we do this, remember actually we have it here, I think. Yeah, this is our API. Okay, so we copy this, go to Python, and paste it. That's it. Okay, so because that API is only listening, then it's listening already. Cool. So we are already connected to it. Now we have to have a folder for images. Upload folder equals. See that? It's just crazy. The static / uploads. Now we will create static and templates folders. Okay, that's how Flask works. Okay, let's just finish with Python first and then go with HTML and CSS. Okay, cool. Now we have to do always to make theirs. Let's just make sure that we have upload folders. Up. Let's just do this because it's faster. I know my timing is not the best today. If it exists, okay, equals true. Oh, come on. True. Basically, what we're saying is true. There we go. So basically, what this says is create an upload folder. If it exists, don't break everything. Just tell me that it exists, and that's it. Okay, cool. Now, app.config, we are going to configure upload folder, and this configuration would be upload folder. This is going to be used. This is a Flask configuration variable. Okay, cool. Now, that's a lot of Flask. Let's work with this. We use at and then app.route. So what route? Cool. Now, what does this mean? What is an at in Python? At in Python, these things over here, are decorators. Decorators are interesting. They allow you to overwrite some parts or extend some parts of functions without you writing the whole function again. Okay, it's kind of like that. So we are taking app.route. Shoot, I have two mice. There we go. App.route. Here it is, and we will be adding the wrap a function. Yeah, it's kind of like wrapping a function, but you can add stuff to it. Okay, so basically, it's like object-oriented programming, but without it to being an object explicitly. But yeah, it allows you to work with them. Cool. Now we add a slash. Usually a slash in web dev is like the main page. Okay, so for the main page, the main thing that will be rendered will get two methods, which there will be get and post. So what does this mean? Get requests are requests that HTTP uses to render. Okay, it means a get is, hey, I'm just asking to enter this web page, something that if you see, the API doesn't have. It doesn't have a get request answer, so it doesn't answer. Okay, cool. Now, and we have the post too, because we will be talking to our API. Okay, nice. Def home, just because, you know, home. We will be doing, first of all, let's see if it's a post or a get method. Okay, so if request that method double equals post, we'll do something here. Okay, so to pass. Else, okay, literally, or not an else, we can just do return render template. Okay, render template is get an HTML file and render it. Okay, index.html, which we'll be creating in a second. File name equals none. Now, what's that file name? File name is a variable that we'll be needing to access our API. Okay, in this case, we don't need the API per se, because we'll be just rendering the whole page. Okay, cool. Now, that's if we don't post. If we post, it means if we send an image through this web page, let's talk to the API. Okay, so first of all, let's make it robust. If file not in requests that files, then return no image uploaded, and probably a 400 error. Okay, so if we click on upload, there is no image, then we'll get an error. Okay, probably not the best thing. The best thing would be to ignore it, but just for sakes, let's do it like that. So file equals request with files and with the name file. Okay, so that will be our file. Okay, that's going to be our image. Now, file path equals os.path.join should be app.config. This basically is creating a path to our image. It's doing upload folder. Should be like this. And here we have file.file name. Okay, so with the name of the image. Okay, so we are going to create a path to the folder with the new image, basically copying the image from one place to another. What? Wait a second. There we go. File save. File path. Cool. So that's basically taking an image, copying it, and saving it. Okay, basically. Now, send post to API. Okay, response equals requests. Okay, this is the interesting part. Requests the post. Okay, we have API URL. Okay, we have files equals image, and this image will open file path reading and in binary. Okay, cool. Now, basically, we will post to the API URL this image. Okay, cool. So far, so good. Now, we could be getting a response or not. So, if response dot status code double equals 200, 200 in HTTP requests is okay. Okay, so 100 is message, 200 is okay, 300 is redirection, 400 is internal server error, 500 is external server error. Okay, so if it's a 200, means okay. 220, 230, okay. Everything in the lines of 200. Okay, cool. Something will happen. Okay, we'll code that in a sec, but else return error in processing. Yeah, when you work. Okay, so just a little bit of an FYI. All of this I learned it when I was a fellow in the Meta production engineering or SRE track. You can visit MLH fellowships, and I'm a pod leader there. So ping me on Discord if you want more information. But yeah, I learned all of that there. Cool. Okay, a little bit of an ad there. Nice. 500, which is external. Okay. Cool. Now, result equals response the JSON, and we do this. Okay. Cool. Now, we know this should be returning colors. Okay. Now, the thing is, it returns colors alongside numbers. Okay. So it will say, okay, it has 50 pixels of red, but 200 pixels of white. Okay. Let's try to render that in an HTML. Okay. Cool. So we got the colors. Now let's adjust them to a CSS friendly. Okay. Cool. So get colors. Cool. Prediction equals result dot get. It's called colors. Shoot. Colors. If we don't get anything, please return an empty list. Okay. Cool. So color names equals should be item 0 dot to lower, and explain why in a second. Dot lower for item in prediction. Okay, cool. Now, why we have to do this? Remember in our API, no, it was pet classifier. Okay, let's take a look pretty quick. Colors will be returned in this format. Should not that much, like this. So you see it's all capitals. CSS doesn't like capital letters. So we have to lower them. And that's basically what this function is doing, or this line. It's just lowering every single one of them. Okay, cool. We return a render template. Okay, with index.html. Okay. File name equals file name, because we'll need that name. Okay. And colors equals color names, which is this one over here. Color names. There. Cool. So far, so good. Okay. What if we don't lower them? Is it important in Python? Ooh, that's a great question. I'll just leave that question there. We'll try it lowering and without lowering. Okay. Well, let's see what happens. But that's a great question though. We'll try it. Let's see how it reacts. Okay. Cool. Now, nice. So that's basically everything that has to do with Flask. Okay. Now, as always, in Python, if dunder name double equals dunder main, then please app.run host. I want the host to be my own computer. Should be 0.0.0.0, which is this computer over here. Port equals 8000. 1, 2, 3. Yep. And debug equals false. Okay. And then why is this import 8000, but this one is in 5000? Like, what would be the difference? What happens if we put the other one import 5000? What happens is it'll clash. So a port can be used only once, or like not only once, but per, or like just once per process. Okay. So if something is using 5000, at the same time want to access it, it'll say, nope, this port is already closed. Okay, like no, something's using it. Okay, exactly, it's busy. So we use something that's usually not busy, which is 8000. Okay, you can put any number. I'm not sure. I'll have to double check, but I think it's over. If you put numbers over 2000, should be okay. Okay, because there are some numbers that are specific for processes, like 443, which is HTTPS, 80, which is HTTP, 22, which is SSH, so far and so good. Okay, cool. So nice. That's app. Okay, now how does Flask work? We have to create a file, a folder called static, and we have to create another folder called templates. Okay, that's how it goes. Okay, we have to do it. Now, inside of templates, we have to have our index.html. Okay, so templates, index.html. Cool. Now, how was the thing? Was it like this? HTML5? Shoot, I forgot. Should I? Will I be able? I think I have to type everything. Shoot, I forgot how to do this. HTML5. Yeah, there was a shortcut in Visual Studio that I don't remember how to do it. But okay, let's just do it pretty quick. Um, it's doc type, document type. It's an HTML. Okay, it's for the computers to understand. Um, HTML, the language equals English. Okay. Um, now we have a head. Okay. HTML, yeah, head. Cool. Now instead of the head, we have a meta class. Meta char set. This is so that it understands UTF-8, which is TF-8, which is the type of characters that it will be using. What else? Meta name equals viewport. I have it like this. I'm not sure if this viewport. There we go. Content width. It's okay. 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 Let me try that. Let me try that. Control X. Is it like this? HTML5. No, it doesn't work. I remember I had it, but I don't know if I because I don't have autocomplete in my Visual Studio because I hate it. So I guess I have to activate it. But yeah, it's okay. Like I can do it pretty fast. Cool. Okay, so it's a lot of typing. Actually, it's a lot of typing, and I think I'll cheat a little bit because if not, then it will just run out of time. So, GitHub. Can I cheat? Yes. It does on yours. Yeah, yeah, sure. So, Visual Studio has its own shortcuts. I removed all of them just because they are, sometimes you're typing something, you type enter or you click enter and it types some other thing, and I hate it. But yeah, cool. Here it is. I'll share this in a second. Okay. Cool. I need this. Okay. Cool. Now I'll probably copy and paste the whole thing. Okay. Was it in head? Head is just over it, under it. Okay. It's not cool. Okay. Let me just indent this so it looks better. Okay, cool. Now we won't be adding a CSS file per se. We will just have it like inside of our index HTML. So let's do this. Dot color container. Oh, come on. Dot color container, which is a class name. Container. Open, we close. There we go. And after that, margin top. It's 20 pixels. For display, we have to use flex because it'll be dynamic. Okay, it'll add some colors to it, some box colors, and when it doesn't have a prediction, it won't add anything. Okay, so it has to be dynamic, and the flex allows you to have dynamic things in HTML. Okay, cool. Justify content. Justify content. Center, everything in center, please. Flex wrap. This means how everything is going to be wrapped together. Okay, is it flex wrap? Wrap, yeah. There we go. Yeah, I'm used to Python that I underscore everything, and we have to add a gap of 10 pixels just so it's not that close together everything. Okay, cool. Now we have some other thing called color box. Actually, it's color container. There we go. Color box. Now inside of color box, we will add width. Okay. The width will be 80 pixels. Height will be 80 pixels as well, so it will be a square 80px. Border radius should be 8 pixels, just so it looks a little bit not that sharp. 8px. and border by itself will be of 1 pixel solid, and the number or like the color would be okay, cool, nice, which is like a grayish color. You can see there it's like a grayish color. Cool. Okay, so let me just so it looks better. Yeah, it's like this beige weird color, like a bone color. Okay, cool. Now bear with me, I know it's a lot, but the end result will be interesting. So dot prediction text. So whatever we predict, font size will be 1.2 rems, and the margin top is 15 pixels. Cool. I think that's it for CSS and styling. Okay, nice. Now let's add some body to it. Okay, body. There we go. And slash body. There we go. Thank you. Now inside of body, we'll create a div, which is so for HTML. If whoever is following doesn't know what this means, we'll create a division inside of our page that's called containers. Okay, creating divisions helps us moving around everything. Okay, so you have something in containers group, some other thing in another group, so on and so forth. Okay, makes things easier. Cool. Now, div class equals containers. And let's, there we go. Cool. Yeah. Cool. Okay. Yeah, it always happens. H1. Can I do the thingy H1? H1 enter. No, that's so sad. If you don't, okay, so if you have the autocomplete in Visual Studio, you can do H1 dot something, and you click on tab or enter, and it autocompletes. If you do dot, it gives you a class name. So it's easier to write, but because I removed autocomplete, so yeah, I have to do everything from scratch. Okay, so it's H1, and it has to say upload an image. There we go. And now, oh, come on. There we go. After that, we'll do a form. Okay, so forms are for to submit stuff. Okay, so form action equals, it'll be sending me to this. Okay, the method is, ooh, look at this, posts. We know what post means, right? Like post is this post over here, which is an HTTP request. Okay, autofill has its ups too. Yeah, I know. That's me. You know, it's weird that I use HTML. So you know, because I use Python and C++, sometimes it just makes me mad when it autocompletes for you stuff that you don't want. But yeah, that's it. Post. We will do and type equals multi-part slash form data. Okay, and inside of this form that it didn't close, thank you, HTML and VS Code slash form, thank you. We will do this. We have an input. Okay, type equals file, so we will add a file to it. Name equals file. Okay, and this is require. Okay, so we cannot do anything without it. Button. Okay, button. Oh, come on, it doesn't autocomplete. Type will submit. And we will put upload here. Upload. There we go. So that's the form. Cool. Now, this is something that most of you probably are not used to seeing in HTML. This is called Jinja. If file name Okay, what does this mean? It means, remember when we added the render template here? Actually, here it's more interesting. We added, it's like a function. So we are rendering the template, which is index. We have to render it with file name and colors. Okay, there we go. So these two are variables, and we will check if those variables exist. You can do that using this, using Flask in Python, and it's called Jinja. Okay, cool. So it's like a block of Python, a block of Python-ish inside of HTML. Okay, that's how it works. Cool. So if we have a file name, because in this part over here, we don't see, because it's not a post request, it's just a get request. So if we have a file name, then we will add an h2 that says uploaded image. Okay, and then we will add an image. src means take the image. Yeah, that's fine. It's, let me just do it. It's okay. I'll just do it here so y'all can see. It's Jinja, like ninja, but instead of ninja with N, it's Jinja. It's like, yeah, if I would say Jinja, it's like an English version of ginger. But yeah, no, it's Jinja, like as in ninja. I'll just type it here. Why not? Jinja. There we go. Yeah, there you go. Cool, nice. Cool. So uploaded image. The source will be you have to do URL for, oh come on, URL for static. Remember, we have our images in static. Okay. The file name equals uploads slash plus file name. Okay, so that's the name of the image. Okay, cool. So let me just make sure that this is not here. We have to end this here. Okay, so basically we are looking for in static, which is one of our folders. Okay, file name uploads slash file name. Do we have to create uploads? Nope. Uploads will be created here. Okay. Cool. Automation. Nice. And yeah, the best thing is to add an alt. Let's just leave it without alt this time. Why not? Cool. Now let's check if we have a prediction. So slash if why double? Why did I add a double? I'm not sure. If colors. There we go. So if colors, then why isn't it colored? I'm not sure. Like, give me a second. Why isn't this? That should be fine. Okay, cool. Then h2 okay, and inside of h2, inside of here, we'll add top colors. So we will render boxes of our colors. Okay, cool. Inside of here, we'll add a div, another division. Cool. And inside of this division, it's going to be called class equals what? A color container. Okay, cool. Now remember, color container. See this? The style is added here. Okay, cool. Color container, and let's do a for loop. Can we do for loops in HTML? Yes, we can. With Jinja, we can. Cool. So for color in colors. Yep. And we have to add the and for. Okay. So just to help all of it HTML, let's add it meant for there. We'll create a division per each color. that we'll be using. Okay, so div class equals color box, style equals round color. We have to add color. Cool. And we close the division here. There we go. Nice. Ah, wait a second. I just messed up here. There we go. There we go. So we create a division. Yeah, double check. Yeah, double check the Jinja. Jinja is really cool. We'll add a box of color per each color that we get from the prediction from the AI, from the API. Okay, I know it's a lot. Just bear with me. It'll work beautifully. Okay, cool. Yeah, as long as I have typed everything good, it should work. Cool. Then we have the end4, and then we have to help it with saying, hey, and if, and the same thing for the other if, which is end if. There we go. Okay, cool. Body, and then we have to close HTML here. There we go. Nice. Cool. That's our HTML. So let me double check if I have something in static. I don't remember. Yeah, we do. Ooh, okay. 623. Okay, I will copy paste this. I'll use my cheat sheet once again. Can you use it? Yes, I can. It's my stream. Cool. Okay, so let's copy paste the whole thing. Okay. In the end, it's just styling the whole page. Okay. So we go here. We go to static. Okay. Instead of static, we add style.css. Okay. Style. .css. Okay. And inside of it, you can copy and paste the whole thing. Okay. I'll share with you this thing over here. Let me just share it here. And then copy this. There we go. There's styles. Okay. If you want to copy paste the whole thing, it's there. Okay. Cool. Now, basically, just a quick overview of what it's doing. In the body, we'll add linear gradient, which is like it's gradient from this bluish, purplish color to this magenta weirdish color. Okay, with 135 degrees. Okay, so you're going to see it's like a wave of colors. Okay, basically. The containers, it has to have a background of gray. Okay, that's the gray. We have a button here. The button will have a background color of orangey. Okay, the color of the text will be white, and yeah, we can add like a cursor pointer. So whenever we hover over it, instead of having like the arrow, will be like this pointer thingy. And yeah, that's gonna be it. Okay, cool. Now that's basically what it does. Okay, just because I don't want to type this, it'll take too much time. Cool. Okay, so we have styled CSS, we have index.html. This should be working now. So let's first see if it works. Flask, run. 3, 2, 1. Oh, okay. So first error, module always doesn't have attribute make theirs. Sorry. It should have been. Where is it? There it is. Make dir, right? Probably. Did I mess up with an S? Isn't a valid keyword exists? Okay. What? Really? Wait a second. How can I mistype those things? Exist. It's not exists. Exist. Okay, without an S. Cool. Now, Flask run again. Cool. Exist. Okay. Really? Exist. Okay. Yeah, sure. I'm pretty sure it's like that. Ah, no, wait a second. It's not make deer. It's make deers like this. My mistake. I'm sorry. Cool. Let's try this again. Zero fails, huh? Zero fails. No errors. Okay. You have a big chunk of red there. It says warning. This is a development server. Do not use it in production deployment. Use a production WSGI server instead. Okay. This is basically telling you this is just a dummy version of what you'll be deploying. Okay. We won't be deploying it, so that's okay. Cool. Let's see if this works. Wait a second. Do you see this? This is running in 5,000. I can see that Docker is not running. The API by itself is not running. So let's run it. Should be sudo docker run pet classification. What? How was it? Wait a second. Cheat, where are you? It's with port. Okay, cool. So what does this mean? Run 5,000 colon 5,000 means run the container. Containers port 5,000 is directly connected to our computer's 5,000. Okay, meaning we will not be able to use 5,000 because it's being used by this container. Great. What? What's the statement there? We failed program external connectivity endpoint. Yeah, cool. So, this is an error that we mentioned before. This is working on 5,000. We tried to make this work in 5,000. We cannot do it. Could you all see this? And now it's working. See? So careful with ports. Yeah, exactly. So we have to change Flask app from 5,000 to 8,000. Now this is interesting because in the end we had, where is it? We said here, hey, Mr. Flask, use 8,000. Flask by default uses 5,000. So let's export that. I'll just double check my the command for that because I don't remember. There we go. So we have to use export like this. Export Flask run port 8,000. Okay, cool. Enter. Nothing happened. Flask run. Ooh, see that? Now it's running at 8,000. Now we have two running. One's connected to the other. None of them are clashing because in different ports. Okay. Let's double check what we have here. Oh, cool. This is what we just built. So we have something that says upload an image. We have the button here. Okay. Yeah. We have an upload button here. So let's see what happens. Ready for the errors? I am. Let's see. Let's just file a doc here. Okay. Open. Looks great. Hey, yeah, it looks acceptable, you know? Let me just double. Sorry about this. There we go. Choose file and let's upload it. Let's see what happens. 3, 2, 1, and. Okay, it's thinking. It's thinking. No errors as for now. Oh, okay. Okay. Nice. So we got the doc here. For some reason, it didn't render the colors. Let's double check that in the HTML. But let's see our neural network. There we go. You can see the neural network got a post method. In the post method, it says 200, which is okay. Here you can see we have the get, and we use the post. A post with a 200. Again, 200 is okay. So let's fix this. What was it? I'm not sure. Color box. There we go. See that? There we go. Class. There we go. That's the error. There we go. Cool. Yep. If you change stuff in Flask, you have to restart everything. So Control C this, not the API. Control C this, and Flask running it. Cool. Now let's just upload an image once again. Doggo, upload. It's thinking. The API is doing its own work in the backend. Okay. Cool. Oh, shoot. We have the colors here. Why aren't they where they're supposed to be? They're supposed to be under here. Wait a second. Hmm. What? Where did I mess up? Give me a second. Div. Yep. Mm-hmm. Top colors. Yeah, this is weird. Why is it not? Did I close? Ah, look at that. I didn't close image. Yeah, I didn't close this image. It's my fault. I don't have autocomplete. My bad. My bad. Once again, Control C, Control L. Do it again. Oh, shoot. No, we don't want to resubmit stuff. Again, choose a file. Let's choose another doggo, okay? Let's choose this one first, and then we go with the next one. So, this should work. Hopefully. Nope. Yes and no. Okay, it's not as I want it to be. These 4 colors have to be here. Okay, so wait a second. Let me debug this more. I have an error. Where is the error? Ah, like this. Okay. Based on my cheat sheet, that's how it's supposed to be. Okay. Yeah, continue. Yeah, let's do that again. Hopefully. Nope. Okay. Let's see. Where is my error? Background color. Color. Slash div. Yep. What? Prediction text. Wait a second. What's happening here? Nope. It'll take ages to debug this thing. Okay. I'll probably go. I have an error here for some reason. Color property value expected. Yeah, it's a color. Okay. Color box. It's called. I think I know color box. No, it's not. What? Okay. Let's do a little bit of a magic. Magic, you'll say yes. Cool. That's the magic. Now, what did I do? I just changed to the code that works, okay? Because I don't want to debug this like 3 hours. So let's just do this again. Nothing happened, okay? I swear nothing happened. By the way, the code that works, I shared it before. So yeah, it's in my GitHub. Cool. Now it works. Yeah, that looks good. Okay. So this unit doesn't actually check if it's a dog or a cat. Because what we wanted to do to optimize stuff was to just break down the primary, like important colors and order them based on the frequency of pixels. Okay, so you can see it has white, gray, yellow, red, and black. Okay, let's try another dog. This dog over here. Yep, I probably could have been better if I put it like the amount of pixels inside of each box, but yeah, it still works though. Cool. Now you can see that the colors change. We have a lot of gray. Now, why do we have a lot of gray but not a lot of black? For computer vision, you have to be careful with light. So light gives you a different variable or different color than it actually is. So we can see it black, but probably the computer sees it as gray. Okay, because it's using Euclidean like calculations, so that it says, okay, if it's like 10 pixels away from black, then it'll be gray. Okay, cool. So we have some red. Why do we have red? Like the red doesn't exist. Well, we don't have orange per se. You can see that in our colors. We actually have orange. What? So CSS didn't read the orange. So this should be orange, not red. Actually, we don't have we don't have red. We have orange. Okay, cool. So this should be orange. So we have a lot of gray, a lot of white, and a lot of orange. Okay, so yeah, it matters. Now, There was a question. Interesting question. Let me just find it. There we go. This question. What if we don't lower them? Okay, let's do that. We go here. First, let's stop. Let's stop this. Okay. Now let's go to the lower part which was here. Let's just not lower them. Okay. Let's just have them as they were. Okay. And let's render template with prediction. Okay. Instead of color names, we'll use prediction. Ready? Let's see what happens. Okay. Nothing so far, like nothing bad so far. Let's re-upload it. See what happens. Okay. Wait a second. Did I change it? Am I in the correct one? Unit app. Wait a second. Is it? No, this is unit app 2. No, wait a second. This is not it. Control C. Killed up. Sorry, I was using the other one. The one that also worked, right? Let's see. Not using this one, but using prediction instead. Darn. There we go. Now let's see what happens. Okay, nothing so far. Let's do it again. Let's see if it works. It shouldn't, by the way. There we go. Cool. So what happens? Let's just take a look at our. It doesn't say anything. But then why doesn't it render anything? If you see, if we go to index.html, we are using a color variable for CSS. So CSS uses colors. You can type white, green, yellow. Like let's do this. Let me show you. So let's do white. Actually, yeah, here you can see it. Color white. Let's do color red. So CSS understands variables. It doesn't understand that. Or green. Oh, it does. Oh, wait a second. I don't know why it doesn't work. Blue. Oh, it does. I'm not sure. Okay, cool. Yeah, it works on CSS. Let's see if it works in. Yeah, it wouldn't work. Red. Yeah, it doesn't work because in the end, you're trying to style CSS. What was it? White? Yeah. With capital letters, and it works with a CSS file, but it doesn't work with an HTML file. Okay, that's why it doesn't break. It just doesn't know what you're talking about. Okay, that's why we have lowering and uppercase. Yeah, it's like it happens, you know. That's what we have to work with what we have. But yeah, so if we lowercase it, let's just double see if it works again. Color names here and there we go. That should be working. If we change something in Flask, Control C and restart the whole thing, because if not, it wouldn't update. There we go. Okay, yeah, sure. I'm out of water, but cool. Now, there it is. Now it works. Okay, so that's why we had to lowercase it. It happened to me like yesterday when I was trying to fix it. I was like, what the heck? And then I just realized that it was all uppercase. But yeah, it happens. Cool. Okay, so basically this connected to an API. Let's double check the API again. Let's see if we can see it. It doesn't exist. Why? Again, because this thing doesn't have a GET request. Okay, it means it won't show anything. Cool. Now, this is great. Yeah, it's really fun. You can, with Docker, you can use lots of things. In the end, I'm using something that I created in this model. This model was trained in Collab. Now it's hosted in a Docker, so it's stable and it doesn't use more resources than I want it to use. Make sense? So that's why you would use Docker. In the end, it's an API. Okay, Docker is made to transfer um, to make scalable easier and to have apps move easier. Okay, regardless of where they are. Now, it doesn't mean that you cannot optimize it. You can and you should. If I try to run this Docker inside of my Raspberry Pi, it'll take ages for it to load, so I have to optimize it. Okay, but it usually works. If not, if there's no optimization breach, then it should work fine. Okay, it should work on Windows, Mac OS, Linux, whatever. Okay, cool. Now, yeah, that's kind of what I wanted to show you guys. Um, that's basically it. We can see here. If actually we can do this. If we do /classify, see method not allowed. It means we didn't allow it to have get posts. I'm sorry, get requests. Just post requests. Okay, just here. See, so method not allowed. Okay, cool. Cool. So, nice. This was a very nice stream. I loved it. I hope you all did too. There's my GitHub, both of the links. One is for the code that we just wrote. The other one is for the API. For the API, just follow the README, which is this one. Okay. If you want to change some stuff, use this part of the code. If you want to just run it, this one. Okay. Cool. Yeah, it's amazing. When it works. If it doesn't work, then it's not amazing. Like it's frustrating. But give it time, and Docker is really cool. Docker is really fun, and it's really, really, really usable. Cool. Okay. So yeah, I'll be sending this again. Let's see. I'll be sending this so y'all can. There we go. Y'all can wait a second. Let me just turn on my light. Ooh, there we go. The sun got down and we'll watch it a little. But yeah, that was great. Cool. Awesome. We'll be happy to. And ping me on Discord if you want some help on with the fellowship. Okay, I can help you, give you some tips and tricks and how it works. Okay. But yeah, cool. So there's the link. We have IoT with cloud on cloud part 2 with Alberto. Okay, so Alberto was before me. We'll have this session with you about IoT on cloud part 2. So stay tuned in 15 minutes. And then after that, we don't have another one up until 5 a.m. ET. It'll be discover 3 ways to run your app on cloud part 3. Okay. Very nice. Very nice. Thank you so much for joining. It was a really cool stream. I'm happy to have participated in this Global Hack Week. And as always, happy hacking. And if anything, just ping me on Discord. I'll be there to help. Okay. If for some reason it doesn't work, just ping me and I'll coach you through the code. Okay. Cool. So if nothing more, thank you all for joining. Have a nice evening, night, or day, wherever you are. And yeah, see you soon. Thank you. Bye bye.